will use our phones because I'm going to ask you. So this is 1-1 from our thing. And again, this should be good for, let's see, a few days. Let's see, one. I think this is good. Let's see. Today, tomorrow, which is Friday. Monday. It's good for Tuesday. All right, yeah, so I didn't lie. It's good through Tuesday. So by Wednesday, you'll need to get the book. So this is the same as in the book. It's loose leaf, so you figure out. All right, so we're going to hit some definitions, but I'm going to want you to also kind of maybe look up some definitions so we can see what alternative sources might tell us about some of those definitions. So a variable. So you've heard the term variable before because you've had algebra at some point. Variable was a letter you were solving for, correct? Variables can change. It says on here, it says variables are characteristics or quantities that can be measured or counted. So variables are things that can be measured or counted. So do you think you students in this classroom could be considered a variable? Can I count y'all? Sorry, you're no longer students. You're variables. Give the V. 8. All right, and so there's different types. So each observation produces single outcome for each variable. A sample is a group of observations. Okay, so do you think that somebody could look in that door and make an observation based on what's taking place in this class? Kind of. So what might be some things, in your opinion, what might be some things that somebody might be able to look in that door and just observe from just us? Stirrups bald. You got one bald dude there, he's the teacher. Do you think we could deal with hair color or eye color? Color of shirts? People who wear hats? How many people have earbuds in? How many people are hiding earbuds? They'll never know. Those are all things that observations can take place. Now, you guys, all of you, could be, I could start saying, I want to take a sample. So let's see, we got, not counting me because I don't count. So 3, 7. 25 of you sitting here. Okay, so if you wanted to say, hey, we have an entire population of Stirrup's first period stats class, or whatever period stats class it might be, that is the entire population. But I could then say, you know what? We are going to use something called a random number generator. Because there's 25 people in this class, I could give each and every one of you a number from 1 to 25, and I could use something called a random number generator that I could randomly select a certain amount from my population, which is going to be the sample. Okay? Now, why those things are important now is as we progress through the class, a few things that you might find would make sense. So every 10 years, the United States does something called a census. A census is they're trying to get every household in America to answer a handful of questions. The last census I remember that came out, one of the questions on it was, how many television sets do you have in your home? I mean, this was a question they asked. And then there's people going, stop, this is a violation of my rights. How many TVs you have in your house? Okay. That's kind of silly, but I guess if they feel they're violated. The census is not a violation of rights. It's actually in the United States Constitution that this would take place every 10 years. Now, census, again, do you think it's going to cost a lot of money, take a lot of time to meet with every household in the United States? figure out these 10 questions or these 5 questions, whatever the questions could be. And it could be anywhere from literally how many televisions you have in your house, how many people are living in your house that are not related to you. You know, these are some of the questions that, you know, have and could come up. How many cars does your household have? And just different stuff like that. So they're trying to figure out a whole census. So do you think that would take kind of a lot of time? Yeah, let's face it. If you do a phone call to me and I don't recognize the number, I probably don't answer it. Okay? That might be the same for all of you. Someone comes knocking on my door, let's face it. If you live in an HOA community, the person knocking at your door should be your neighbor. If you don't live in an HOA, you might have anybody else who's trying to gather or sell you something. So a lot of times, you know, especially these days with the doorbell cameras, you know, a lot of times who's at the door? I don't know that person. You ignore it. It's going to be really hard in 2030, I believe, is the next census. It's going to be really hard for them to actually collect data because of the amount of technology that's out there. But a census, they're trying to collect all of the data. Now, if you think about anything in statistics, it would be impossible for me to collect everyone's data. It would take a lot of time, it would take a lot of money. I told you yesterday that I'm going to be starting my doctorate, so I will have to collect data. But I can't collect data on everybody. So there has to be a way that I can take a sample, a random sample, that's the key, of a certain amount of people, and it has to be a certain amount of people in the population that you're dealing with, that becomes an acceptable thing that you start running tests saying, hey, what I found was this, and now I can say, and I kid you not, this is the verbiage we use in statistics, I'm 80% confident, I'm 85% confident, I'm 90% confident, I'm 95% confident, I'm 99.9% confident. So some call confidence intervals will be coming. It becomes one of those things where people think, you know, if I said, hey, I'm 99.9% confident that if I did this study again, my results would fall within this range of numbers. Does 99.9% sound like a really good number? What do you think?
Yeah.
I mean, heck yeah, you get 99.9% in this class, you kick some butt, right? But 99.9% becomes a very broad spectrum of numbers. So I could make a statement like this. I am 99.9% sure that every student that I select from my students that I have this year in statistics, that their grades will range between 30% and 100%. $30 to 100% is like, well, dude, you're like capturing, like, how could you get less than a 30%, especially in stirrups class? It's going to be tough. Okay? But on the opposite end of the situation, what if I were to say, hey, I am 70% confident that if I were to take the exact same type of random sample from my statistics courses, what did I say, 70% confident? 70% confident that my students would range between 50 and 95%. Is that a smaller range of numbers than a right? So it becomes kind of goofy. They kind of invert each other. So a lot of people will see a 99.9% confidence interval when you're reading something as far as statistics goes, and they think it's going to be the gospel truth, but it becomes such a broad spectrum of your sample of people or your population that it's going to go with. And I kind of went on a little tangent, but I'm sorry. So they talk about here on the second paragraph, you have a large group of people at a conference. It doesn't tell us how many people there are. Let's just say you're having a big conference at the Pepsi Center, and the Pepsi Center is full of people, including on the ice or the hardwood floor, wherever They have people that, so there are a lot of people. But you wanted to say, let's figure out the age. Well, the age is going to be the variable we're looking at. And then one person in the group is 45, but another person's 16. So now you're like, well, my variable is now switched. I found somebody in this conference that was 45, and I found somebody in this conference that was 16, that you just somehow arbitrarily, randomly selected. Each of those individuals' age is an observation. Okay? Now, I know all of you are right around the same age. Okay? I would say I would be like 99.9% confident that if I were to select somebody for my statistics courses, that the age is going to be between 16 and 19. Seem okay? I know some of you are thinking, going, there's a 16-year-old senior? There might be. Really? Somebody's 19 years old? They might be. Me being 99.9% confident, that means I have a 0.1% chance that I made an error, that somebody is less than the age of 16 and older than the age of 19. So there's just some different things to start, putting together with this. If you're a meteorologist, third paragraph, keeping track of daily temperatures every day for a full year in Seattle. Well, I mean, I don't know if any of you watch the news. I know that you more than likely just go to your weather app to see what the weather will be if that was to take place. But if you do truly ever watch the news, you will hear things talking about the weather. Our high temperature back in 2004 was this in Denver, and today was only this. So the record wasn't broken. So there's just different things. Some of you might know this, but Dave Aguilera, who is one of the meteorologists on CBS, he used to live down the street from me. And I had the worst conversations with him. He's the nicest person. He really is a super nice person. And I'd, be doing yard work, and he'd be walking by with his kids or his wife and his dogs or whatever. Hey, Dave. Hey, Chris, how you doing? Because my first name's Chris, if you didn't know that. It's like, nice weather. Why did I tell the weatherman? It's nice. Idiot. Dumb. So just kind of goofy. So those are just some things. So if you were to be collecting data and then you were to try and take a sample of 365 days, you could do that. So writing newspaper articles, checking to see when people are born, things like that. This all takes place. Variables, observations, and samples are basically the base of anything in statistics. Okay? Now, let me give you some really bad statistics. This came out in the 1990s, which I know doesn't mean much to you, which is fine, but I'm just telling you this came out in the 1990s. They put on a study, and it was published in every newspaper, because back in the 90s, people actually got the newspaper rather than have all the newspapers go bankrupt. And this study was a full-page article that said they have found that drinking 1 glass of wine at legal age a day is good for your heart. And they had other things in the article, but that was the main premise of the article. Drinking 1 glass of wine a day at legal age is good for your heart. Sounds good. Like if I were to tell you right now that you getting Starbucks every day is good for your health, aren't you going to like that? Would you like me to tell you that the wine study was an advertisement that was put on by the Grape Growing Association of the United States? So you have a company, you have people who grow grapes, and these grape people who grow grapes, obviously a lot make to the grocery store because we like grapes. But grapes also, once pressed down and crush out all the juices, the sugar in the grapes ferment down to, basically the chemistry that's taking place is the sugar drops a hydrogen off, grabs an OH bond, and that's where alcohol comes in. So it's a part of the fermentation process. That's something that really does happen. But just imagine that. People are reading in any local newspaper, as well as the Wall Street Journal and the New York Times, all the publications, they had this there. And all of a sudden, wine prices increased because the demand for wine went through the roof, because people read this, that drinking one glass of wine a day is good for your heart. It was an advertisement. But so many people fell for it. And it's like, well, unfortunately, statistics was used to manipulate sales. There was no truth to it. Okay? Now, would I say that if you had a fruit that is a deep red or burgundy color, do you think that would probably be good for you? Well, yeah, it has antioxidants in it. Based on what? Well, it says on the label on my drink. You go buy some of those energy drinks. This has got pomegranate juice in it, and that's an antioxidant. It's good for you. Based on what? Well, it says on the bottle. It's an advertisement. That the person who brought that out to you. I'm not saying that fruit juice isn't good for you. I'm just saying that we as people, we look and we say, we have to have this. We have to have this. It's good for you. If they come out with a study saying, hey, ice cream, if you eat a gallon of ice cream every day, it's good for you. Man, I'm stocking up. I love ice cream. Okay? Now, variables can be quantitative or qualitative. Now remember, guys, my friends, you can use your notes on tests and quizzes. So make sure this quantitative and qualitative, this is highlighted. If you need a highlighter, you're welcome to borrow any of mine. I got some there. Or if you just want to circle it. But just know, have that there for you. Yeah.
So we can just use this on the tests?
Yeah.
Okay.
Actually, when you get the book, you'll be able to use what's in the book on the test. But this might be part of it.
Just at least for this unit. Yeah.
Yeah, I probably wouldn't use chapter 1 on chapter 2's test. You'd probably be wasting your time. So, but there's quantitative and qualitative. So quantitative variables. So someone do me a favor. Will somebody jump on their phone, get to Google and type in quantitative variables. And this, once you have that, that's fine. But let me read what we say they are, and I'm just curious what Google might say about it. So, and I might, because I'm looking at your seating chart, I might pick you. So this is, everyone gets to participate. So I want you to look up this for me on your phone. Okay, do not tell me what it says yet. Quantitative variables. So what we say in our book is quantitative variables are numerical in nature. They measure or count some characteristic, temperature, age, height, weight, grade point average, ACT score, length, pH, which is a chemistry term, the position of a finish in a marathon, the number of wins in a football season, the inflation rate at a time that it takes place. Hey, that for me?
No, it's not for you.
I'm sorry, you gave it to me.
I know.
Okay. Sophie, where you at? See ya. You got a plastic bag with something in it. Yeah. The time it takes to fly to a certain city all provide numerical outcomes. All those variables are quantitative. Okay, so let's do this. Olivia, you came in late. Give me a number from 1 to 25.
17.
17. Let's see. Colton, give me a number that's not 17 from 1 to 25. 10. All right. Brady, did you find something on your phone that's quantitative? If not, give me a number from 1 to 25. That's not 10 or 17.
25.
25? All right. You're 25, Coco. Right, Coco?
Yeah.
Yeah? Did you look up quantitative?
No.
Hold on. All right, Skylar, being you're on task, what does quantitative say?
It says this. Quantitative variables are any variables when the data represents amounts.
Say that one more time.
Quantitative variables are any variables where the data represent amounts.
Amounts. Okay. So from Google, so is an amount temperature? Is an amount age, height, weight, grade point average, ACT score, length, pH, position in the finish of a marathon, number of wins of a football season, the inflation rate at the time it takes, and the time it takes to fly to a certain city? Does that fit in with your definition a little bit?
You got that one.
But say it one more time, please.
The whole thing.
I think you can do it.
Okay. Quantitative variables are any variables where the data represent amounts. For example, height, weight, or age. Categorical variables are any variables where the data represent groups. This includes rankings, mission places in a race, classification, example brands of cereal, and binary outcomes at the end of conflicts.
Perfect. So my friends, on that worksheet there, make sure you have highlighted, indicated what a quantitative is. Maybe circle that. So when we have a test or a quiz, your eyes are going to find that. And that's just coming from, I know that there'll be certain types of question for you. Okay? Okay? I just want to make sure you feel comfortable with that. Okay? Quantitative. Okay? Now, the next one, and again, you saw how I'm going to pick people. And I'm going to be a little stricter on this one. I want you to look up on your phone, Google search, a qualitative variable. And while you're doing that, so they are called categorical. Merely provide a label or characteristic like hair color. Very good. Hair color, ethnicity, gender, the state or country of your birth, your favorite color, the make and model of a car you drive, and your blood type are all qualitative. And qualitative is also sometimes called categorical. Okay, these are different variables. Does somebody volunteer for me who I haven't picked on yet? What Google is saying about what a qualitative variable would be? Anybody? Yeah.
Qualitative variables are those that express quality attributes such as hair color, eye color, religion, favorite meat, gender, and so on.
Cool. All right, so friends, make sure you have it down, especially in your notes. There is a big difference between quantitative and qualitative, and the qualitative is also can be called categorical. Okay, make sure you know the difference between the two. I mean, and again, I'm not saying memorize it. Make sure you have this on your paper so when we have a test or quiz, you know that it's going to be there. Okay, so some variables might appear to be quantitative that are actually qualitative. So things like your social security number is certainly numerical, but its purpose is to simply provide a label. It's like your student ID number. It's the same idea. Okay? It is a number, but it's there for a label. No two people at this school, as far as I know, unless there was a goof up with the registration, no two students should have the same student ID number. Agree? So that's going to be a little different. This is getting goofy on me. Oh boy. I can see how this day is going to go. All right, so that's kind of the ins and outs of there. I'm on the back side, so on page 2. Okay? So it had said that your social security number doesn't measure anything. Therefore, it is qualitative. Again, like your student ID number. Maybe right by social security number. Maybe say also like student ID number. Okay? That would mean something. Watch for variables that are numerical but only provide a label. Okay? Watch for variables that have a number value but it's only for a label. Okay? Quantitative variables may be discrete or continuous. Oh, wait a minute. Discrete or continuous. That's like an Algebra 1 term that you probably all forgot because you had a cruddy Algebra 1 teacher.
Mr. Wiggins was my algebra 1 teacher.
Oh, you might know then. All right. What's the difference between discrete and continuous?
Continuous is that it's like constantly going, like they produce outcomes in a period that can be measured accurately to many decimal places.
Okay. Yeah.
Yeah. And discrete variables are usually limited to a number of.
So you had a really good Algebra 1 teacher. Any of you who had me had a bad one, so sorry. So continuous. Things like temperature is continuous. Even though your thermostat might only in your house would go from 74 to 75 degrees, did the temperature between 74 and 75 degrees, did all of the decimal amounts and fractional amounts between 74 and 75 actually take place before it got up to 75? And the answer is yes. It's just your thermostat's going to, it's going to jump as far as you put numbers in, and that's pretty fortunate because, you don't want to turn your thermostat down going, hey, Dad, do you want it at 74.27373721386753009? No. Oh, this dial's going to take forever to get to what he wants. No, it's very fortunate. You go to a whole number, but all of the temperatures in between do exist. So that's continuous. Discrete, my friends, all of you are discrete variables. Doesn't matter if you're tall, short, bald, or have hair. Notice I pointed myself as bald and have hair. We all count as a person. Okay, so we are discrete. So if I can go in and say, you go out over here to the park, you might see some squirrels. You're not going to see 2.67 squirrels. You're going to see 3 squirrels. One might be small, one might be big. I don't know. Depends how much you guys have dropped on the ground and make them eat. Continuous variables produce outcomes in theory, could be measured accurately to many decimals, as we just learned. Continuous variables have infinite number of outcomes on the interval you may choose. So there's a distinction between discrete and continuous. It's important. Discrete are trapped into specific outcomes. The number of students absent from a class might be 0 or 1 or 3 or 8. It is not, but it's simply not possible for 1.5 students to be absent from class. Okay, even if someone's standing halfway in and out of the doorway, you would still count them. Okay, discrete include ACT scores. They include IQ. They include the number of emails you receive each day, the price of gasoline, and the number of siblings you have. Continuous variables are more flexible, the amount and precision, and the outcomes can be chosen by a researcher and be based on the instrument in hand. And then beware, many continuous variables will appear to be discrete. When you discuss the height of people, it's very common to say that it is in feet and inches. The number appears to be discrete, but please know that someone who is 5'9", which is supposedly my height according to my doctor, I might not be exactly 5'9". I might be a little above or a little bit below. Who knows? Okay, so if you got everyone who said I'm 5'9", I bet you could find a little bit discrepancy depending upon your measuring tools. If they are really accurate, you could find the heights are a little bit different, even if everyone's saying that they're 5'9". So, my friends, my thing is getting goofy. So let's see if I can make this work. Page 91, 91, and 92. Hello. That says 91 and 92 for those of you going to do it. Here, we're actually going to make this easier. We're going to go enable touchback. And I can do this. Let's see if this works. 91 and 92. Yay, found it there. Try it. Give it a good try. Give it an honest try. So tomorrow what I will actually do before we even start class is I will come around to see if you attempted 91 and 92. You want to get the 4 out of 4. You don't want the 0 out of 4. Don't be that person. And my friends, that's all I have for you for today, if that's okay. Fortunately, but unfortunately, you have to stay until we're done. We're done.